Hello everybody and welcome to this video where I will be discussing an ongoing windstorm in the west and the potential for it to become our next nor'easter in a few days. Now before I get into the video, I would like to thank you all for subscribing. I now have 15 subscribers, which is pretty little compared to other YouTubers, but I'm really grateful for that. I see that my videos are being watched some more, so thank you all for watching my videos. I only have 4, but I plan to upload once, like 3 to 4 times a week from now on, including time-lapse videos, and once I get 1,000 subscribers, maybe I'll do live streams, if I'll get 1,000 subscribers, that's all up to you guys. So that's my plan for uploading for the next few years. But, so let's get into this video. So like I said, this is a windstorm right now. If you see these lines on, this is the HRR model. It is a short range model, very short range. So this is the 18Z run, which is the one that goes out to 48 hours. But as you could see, the tighter packed these lines are, the stronger the winds are. So this is tonight. This is a forecast. This is for tonight. As you could see, these lines are pretty tightly packed. So this is pretty strong winds. So let's go forward a bit. Watch these lines. They get tighter and tighter packed. This could be wind gusts up to 60, 70, maybe even 80 miles per hour in this area. This would be around North Dakota, South Dakota, Minnesota, places like these. This could get pretty strong winds. This would be late tonight, early tomorrow morning. So watch out for that. But pretty much winds, probably not much rain out of the system in the Midwest, but definitely strong winds. So a lot of trucks could be overturned on high-profile vehicles on the highway. So yeah, watch out for that. Now, let's get into the nor'easter part of things. So after the storm system moves through, as you can see, moves through the Midwest, a piece of it starts to dive south, while the rest goes up north into Canada. So this little piece that dives south develops a new low pressure system, its own low pressure, and basically it starts to spin around an upper level low. If you don't know what an upper level low is, it's basically a low in the upper levels. It doesn't produce any rain or snow. It's a vortex in the upper levels, a large vortex, and most of the time storms tend to spin around the low. So as you could see, this new low that forms the surface low, the storm, starts to spin around the upper level low. See that? And also, don't ignore this little stripe of rain over the Gulf of Mexico, because that is going to be our next nor'easter. Now, let me zoom into the eastern United States so it's easier to see. But as you could see, this little stripe of rain starts to develop lower pressure along it. As this main storm starts to spin over the Great Lakes and weakens, the secondary low forms along the cold front. So this stripe of rain is actually part of the cold front of the main storm that forms along the Midwest. That's the cold front of that storm. But it develops a new low pressure system over it. And watch this. This model isn't as aggressive, but this low pressure moves up the coast and spawns snow for Maine, northern parts of New Hampshire, Vermont, but mostly rain for the coast. This would be pretty like not eventful storm, but still, this is one of the models that are on the weaker side. If I could show you more other models that are much stronger, but regardless how strong or weak the storm will be, there will be a lot of lake effect snow showers and pretty much regular snow showers behind it. As you could see, all this white stuff, that blue stuff, that is all snow showers here. And these snow showers have the potential to bring whiteout conditions from literally, you could be driving down in West Virginia. You could be in sunny weather, then you take a drive like 20 miles on the highway and you're basically in a blizzard. That's how they work. Snow squalls, gotta watch out for them. So then you could see some of these snow squalls might reach areas of Pennsylvania, possibly New Jersey. I don't think they'd make it to the coast, but that's still 84 hours out. Let me check the sounding in here. Yeah, it would be about 39 degrees, so it'd be more like either grapple showers or rain showers. I don't think it'd be snow showers at that point. But if you don't know what grapple is, it's basically like snowflakes and ice, like snowflakes coated in ice that fall out of the sky, sort of. It's a type of precipitation not really known. But basically think of it as hail that doesn't bounce. It's soft hail basically. Now let's move on to the Canadian model. This is one of the more aggressive models with the secondary low forming. So as you can see, the Canadian shows the same thing. Part of the storm going north into Canada, weakening. Another part diving south, developing a new low pressure over it around the Midwest. Then starts to spin around the upper level low. But watch this with the Canadian model. The Canadian model, this upper level low develops, number one, further west, and the upper level low is stronger sooner. So as you could see, this develops at 12Z Saturday. This has a 994 millibar low pressure system over New Jersey, Pennsylvania border. Meanwhile, the GFS model, get rid of the sounding quickly. So that would be 12Z Saturday. At 12Z Saturday, the GFS has the low pressure system in the Gulf of Maine, much weaker, 999 millibars, while the Canadian model, the CMC, has a 994 millibar low pressure system, which is stronger, over New Jersey. So that's the difference. So there's some models showing stronger nor'easter. Well, this technically wouldn't be a nor'easter, but coastal storm, let's just say that. So the Canadian model is one on the stronger side, and the GFS model is on the weaker side. Now, since the storm is only 72 hours out around, we could start looking at the a short range model, such as the NAM. So let's take a look at what the NAM shows. So as you could see, it shows the piece of energy diving south from the main storm, and it develops a low pressure system similar to the rest of the models. Actually, the storm could bring some snow to Chicago, I just realized that. So yeah, the NAM model is also more like the Canadian model, more on the stronger side. It develops the low into a 993 millibar low pressure system. Now this would be a nor'easter. This would be technically a nor'easter. 993 millibar low pressure system off the coast of Long Island, Massachusetts, with snow on the front side, and pretty much rain over and to the right of it. So also, I don't know if I mentioned this yet, but a stronger storm would mean more winds coming, would mean a colder outbreak after the storm, and a stronger storm would mean more lake effect snow after. Because think about it, the winds around the circulation of the storm would be stronger, and you need strong winds and cold air over the Great Lakes to produce lake effect snow. Once you have the stronger the winds are, the more lake effect snow you're gonna get. So look at this model, showing much more lake effect snow for Ohio, Western Pennsylvania, and West Virginia. So that would be the difference between a weaker storm and a stronger storm. Now let's take a look at the RGEM model. The RGEM model is more of a, let it load for now. Yeah, so RGEM model, same as the other models, develops the low pressure system, spins around the upper level low. RGEM model is similar in that way. However, the RGEM model develops the low pressure system also like the Canadian earlier, and this would be some pretty heavy rain for Long Island. This is sort of like, the RGEM model is the closest model after the Canadian, which has also a 994 millibar low pressure system over New Jersey. So the RGEM and the Canadian are almost right on top of each other, and then as you could see, lake effect snow behind the main storm passes. And actually the RGEM model shows some of the snow showers entering parts of New York City too, but I wouldn't buy that yet. Still way too far out. Now let's take a look at the circulation of the low. So what I want you to notice is this is the low pressure system right now over southern Canada, and you could see this line over here. This is its cold front. Actually, this is its warm front. So this is the warm front of the low. The cold front is way back here, all the circulation over there. So this low is supposed to travel southeastward into Minnesota, and it's going to elongate. And the northern part of it's going to split and head up toward Canada, while the southern part's going to split and head southeast. And then you're going to notice like a big circulation forming here, and then you still don't see, but some of this spin over here over Mexico, yeah, believe it or not, it's over Mexico right now. It could travel northward, connect with the cold front, and cause a secondary low to form here, and then come up the coast. So as of now, this is the storm right now. You could see the bright pinks. That's the circulation. Actually, this model is really good for forecasting hurricanes. Well, not model, the spin. This is really good for forecasting tropical cyclones, so I might use this to make videos later in the summer. Now, the NAO, let's get into that. The NAO is pretty negative right now. It's not like far negative, but it is negative, which is all that matters. The more negative it is, the slower the storms move. So you notice how that low pressure system coming from the Midwest is gonna stall out over the Midwest. It's gonna stall out like over, I don't know, like the Illinois areas like that. So this is partially the cause of that, the NAO. When the NAO is negative, the storms typically move much slower, and when storms move slower, they stall. So this storm is stalling partially due to the negative NAO. Now, I want to show you this. This is very interesting. Look at the AO. The AO is now closer to neutral, but watch this. This is some crazy model guidance. This is just insane what they're showing. Dips toward back into the, what is this, like, yeah, -3 degree checkpoint around January 16th. Then it spikes up a tad bit, but look at what some of the models are showing. Some of the models take the AO so negative it's literally off the charts. I don't think that's gonna happen, but it's just amazing what these models are showing. So I would pay attention to that. So the more negative the AO is, the more severe cold you get, basically, the weaker the polar vortex. I already talked about that in another video. So thank you all for watching this video. Please subscribe if you like this content that I'm making. And yeah, see you in the next video.